you for your patience. What? Yeah, I know. Toys are a challenge to hand out. You all know this better than I. Be careful when you hand out what. So, hi, I'm Mark Lucas. As Gong said, I teach here in physics. My main job is the algebra-based physics sequence here. I also do the Ohio Honors Program, if you ever have questions about that. But the other thing I do on the side is I play. I'm on the board of the Ohio Valley Museum of Discovery. We just opened our permanent home up on Columbus Road, and I'll talk about that a little bit later. I've been running physics open houses when we can manage to swing them and things like that. As part of the play, I love dabbling with electronics, with programming, and such. One of the things I've happened upon is something called the microbit. And my first question for you, raise your hand if I say scratch and it means something to you, besides itching, okay? Arduino, microbit. Cool, then you're gonna learn something today. Okay, I'd like to get a feel for, because these are out there and I know teachers have been using them for years. So hopefully this will get you some extra interesting information about some opportunities. You may or may not be working in pairs. Doesn't matter at this point. I think we're good there. And we are going to use the Google Chrome browser simply because what they call the web USB makes it a lot easier to download programs to the microbit. So you just press a button instead of putzing around on the screen. A little bit of history about myself, my computing journey, right? I'm a physicist. What do you mean computer science? Well, I'm a physicist who started on that thing. Anybody ever seen one of those? I was in 8th grade. Dad got one for work. He was a health physicist in industry. And he got one for home. It had 8K of RAM. You could save your programs on the cassette tape. And it was only 800 bucks. Okay. My journey goes to lots of other stuff. I was doing VAX 11 780s for Purdue and Illinois, and then moved on to an HP Unix station and the like. But I came full circle when I started to play. One of my friends said, "You ever heard about this thing called an Arduino? I think you'd really like it." All right, I said, "Oh, okay." If I say microcontroller, what does that mean to people? Does that mean anything? Okay, good. So we've got something to work with. A microcontroller is really just that. It's a tiny controller. And so it's really a small computer. Actually has a little bit more memory than my original Commodore PET, but only costs about 20 bucks or 10 bucks if you get some of the Arduinos. It is a small computer. It will run a single program for the most part. And then what you have are things like input and output pins. So here you could figure out whether a button has been pushed, or turn on a light, or look at a sensor and figure out what the temperature is, or how much light is shining on it, or what the force is. You can bring the information in, write a little program to process it, and then spit information back out. Open and close gates, move motors, all this kind of stuff. And the cool thing is, we're talking 10 to 20 bucks, a chance to practice some electronics, build them into little robots, all these kinds of things. Now, microcontrollers are everywhere. I don't have that slide on me right now, but your refrigerator. How many people have a semi-intelligent refrigerator? How many people have a refrigerator that's more intelligent than you want? Your cars, your microwaves, everything. There's a little computer in there saying, oh, they push this button, now I start the motor on the fan for the microwave, etc. They're everywhere. And these have been turned into boards that are very accessible to hobbyists, for education, for prototyping. Hey, I don't want to build my official thing and design really fancy boards, but can I just see if this will work? All these kinds of things. And one of the more recent things that have come to life is the microbit. Now, the microbit was designed, or I never quite got this straight, sort of contracted by the BBC to be able to have something that's inexpensive that you can put in the hands of every kid in the United Kingdom. And the deal was that it just blew up, right? They did it there, and hey, this thing's really nice, and it has taken over the world by storm in some ways. Let me tell you what you've got on it. Here's a tiny little board on there. You have 2 buttons that you can see. You have a touch sensor, that little sort of thing with 2 eyes at the top. If you touch it, it will tell that you're touching it. There's an accelerometer. It tells you what the acceleration is, but as well it tells you where G, the acceleration due to gravity, is. And so it can tell if it's tilted. It can tell it's been shaking. It can tell if it's being dropped and it's in free fall, which you hopefully don't want to do. But who knows? A compass, a light sensor, a microphone. These are all inputs that are built in. What's the advantage of that? You don't have to hook up the wires. You don't have to worry about whether your wires are broken. You don't have to worry about whether you plug them into the wrong holes in the breadboard. 25 LEDs on the front. You've already seen yours blinking at you if you've turned it on. A speaker. So version 2 has a microphone and a speaker built in. All of your microbits are version 2. Communication. There's radio communication between microbits. You can set up a radio channel. I can't remember what frequency it's on. There's also Bluetooth, and there's USB. 20 bucks. I'd say that's a pretty good deal. Kid sits on it. You know, it's not dirt cheap, but you don't cry like you would for a $1,000 laptop, right? So a lot of stuff built in. You also have some connections that allow you to hook up some things pretty easily. And then connections that will let you hook up things with a lot more work as well. So my thoughts on this, why the heck would I care as an educator? Why would you care as an educator? The microbit, self-contained and has a lot of stuff in it already. All right, so the kid doesn't have to add on extra things before they can really start having some fun with it. The second thing is that it's fairly inexpensive. There's a huge online community, international, global community, just like with the Arduinos. I dabble, and I'll talk more about this at a later point, I just dabble in the community at these kind of maker-like things, and I really try to go for the inexpensive, heavily supported, as free as possible kind of devices and systems. It has block-like coding. How many of you have written a program before? Okay. How many of you have cursed the semicolons and the parentheses? And yeah. All right, block coding, you're dragging blocks around and then typing into circles and stuff, what kind of numbers you might want. You're dragging things and they click into the right place but don't click into the wrong place. When you're just typing out your program, trust me, there are a lot more ways to screw it up. So block coding is a good entry level for anybody of any age starting the coding. It'll take care of a lot of details and let you think more about what it is you want to do. Scratch is something that kids as young as first, second grade can start working with Scratch. It is purely online. I'm not going to talk a lot about it, but scratch.mit.edu. You can go there and you can drag blocks around and make balls bounce on the screen and things interact, and Scratch the cat will work through. You can tell it to move, you can tell it to do certain things if you press keys. Kids can start doing this kind of work when they're very young. They can also start getting to understand the microbit as well, sort of young. I probably wouldn't stick it on a first grader, but a third or a fourth grader can start to at least make it make sound. Hey, if I push this button, please make this face and play this sound. There is also, to combine the two, a Scratch extension little bit of a pain because you got to run a Bluetooth something in the back. They call it Scratch Link. But you can use, and my laptop's not being nice with the HDMI. If it were, I could show you me holding a microbit, and when I push a button, it communicates to the computer, hey, a button was pushed, and or when I tilt, and say, you know, if the microbit's tilted, so you can turn it into a game controller. But on the flip side, when you get into MakeCode, you're going to also see a little window up there that says JavaScript. Or if you do the drop-down menu, Python. This thing grows with kids, is my take. Now, I'm more talk than do, because I still haven't had the chance to watch it grow with kids, but they can do Python, they can do JavaScript, you can do C++. It can get really sophisticated. So you can start here, and with the same device, the kids can mature in their technology, so to say. So it can grow with the programmer. You can also expand the hardware, and I'll show some things like that a little bit later. Why code, right? Personal thoughts on coding. Coding isn't just about getting the right commands. It's about the mindset, how to give good directions, right? How to communicate. I collaborate a lot with Debbie Brewer at WOUB. She has books like this. And this has actually not a single line of code, but it says, hey, if you're a coder, you need to learn how to give good instructions. You need to learn how to figure out where the instructions are wrong, how to go back through and rethink stuff, things like that. And so that's part of what we're trying to teach the kids of all ages. Thinking through, if I want to do this, what do I really need to do? And the biggest thing, which I will say several times over, is failing. Kids, how many kids like to fail? Right. How important is it to fail? Yeah. You know, I had a kid I was working with, 10 years ago. He's now a first year student here at OU, and he says, yeah, when I was doing that stuff with Athens Makers, what I really learned was how something wasn't going to work. And I just stepped back and say, why didn't it work? Instead of, oh, didn't work, I'm gone. All right? That is what we need. I presume that's what Intel needs. Somebody's going to step back and say, wait, why isn't this working? Not, oh, well, somebody else will fix it. Representing the world with data. This is an abstract concept that I chew on some. How many of you think about the fact that we can digitize this room and turn it into just a bunch of numbers? Right? We can talk about any type of data. It's just a bunch of numbers and letters and stuff like that. That's a hard concept. That's probably a hard concept for everybody to wrap their heads around, right? But that's what we're doing in programming to some extent, finding ways to represent the world, and you get some number sense out of it. The other thing that I'm a big fan of is making things happen. Kids don't want to do spreadsheets or, my data analysis for my thesis was, reams and reams of coding to get histograms and this and that and make the cuts and keep my data organized. Nah, that's not what they want to do. They want to write a game, all right? They want to make things bounce on the screen. They want to do silly things that annoy their parents. They want this robot to go bouncing across the floor. So that's one of the things that I try to keep in mind as I'm working with them. A lot of it's about, first of all, learning what's possible, right? As we look at MakeCode, I'm going to have you just look at the different commands that are possible, and then trying things. Then you step back and say, I've got a problem I want to solve. What do I really want to do? Come up with the idea, code it, see if it works. You're used to a computer that can run lots of things at once, all right? The microbit will run one program at a time. But when you basically create it on your laptop and ship it over onto your microbit, it stays there. If I risk 20 seconds and pray it works. I've got here a microbit that I coded for a step counter. And you actually, on the sheet that I gave you, have some very basic code for a step counter. And so, even though I haven't turned this on for a couple of weeks, that program's still there. I hope, I pray. I get the little heart that tells me it's alive. And I shake it. Shake it again, that's 2 steps.
Oh my goodness.
3 steps. 4. It's not quite as good. 4 steps. Then 5 steps. Gotta have a reward. I get my reward at my 10,000 steps. Here, we're just gonna cut it down to 5 steps, right? But that program is what's going to run on this microbit until I download another program over it. When you turned them on, they all started doing lots of dancy things on the screens and things like that. That was the standard program they download on a brand new microbit. We're gonna write over that. So, 1 program every time you start it up. That's one thing to keep in mind. We're gonna use Google Chrome because we can hit that little download button on the website and it should just work. Here's what we're going to try to do, and a little grumpy that I can't. I'm going to see if I plug your microbit into a USB on your computer, and take Google Chrome and go to makecode.microbit.org, and I'm not going to look at you. I get one set aside.
It's the beginning of the day. It's the shaking. So let's get started.
So, are people able to find makecode.microbit.org? I'll look up here in a second and see if microbit's in there. Okay. So makecode.microbit. If you just go to microbit.org, you get their main website. Okay. I am going to real fast walk you through the first bit, and then we can see where we go from there. We can be very creative. Stuff 01. Your screen should look something like this, where you say, no, I'm not going to take a tour. Do you want to rotate a little bit? Yeah, do you want to just see it? Nick's going to wander around and help out with any little tidbits. Are people seeing something that looks so like this? So when you say new project, I may have gone a little bit past because
so you're going to makecode.microbit.org. Yep, you're good.
First you need to get your
Close.
No.
Yeah,
that's
right. So you're good.
Make that
Try using that and see
to
if,
change.
but I don't know.
You're old.
We're going to put makecode.microbit.org, otherwise it takes you to
It's like being in class with your mother, isn't
You're good.
Oh, is she trying to tell you to behave?
Yeah, make code.
Let's see if it, so there.
Did you choose new project? Is that what you did?
Yep, so if you
Okay,
click
we
on
love
new
it.
project, you'll come into the program editing area.
Oh, you did?
Create project.
Oh, you have to put it in
There's
the
a real
so it's a drag and
quick
drop
something.
into the coding structure.
Every program
So click drag.
by default has a
Drag it
start
to-
and a forever.
Wow.
Everything you put in
Yeah,
here
you're just
you'll
watching
do once
something
at the
like that.
beginning, And then it'll just start doing this. And then you can put other things around it.
Good.
Now,
Yep, just give it a
on
name.
the side, you have a bunch of different commands. So I'm going to go to the basic menu.
We're good? Yep, you're
And I'm
exactly
going
where
to
he's at right now.
show, I'm going to drag that in, and I can adjust whether this is the big heart or the small heart. And then I'm going to go, see, I know in advance that I want to then pause. I'm going to drag that in. Takes a little bit of work to get used to how they're going to click in. I'm going to pause it for 1 second. I can even do a copy and paste. So I can copy and paste this in. I don't know how Chris or Jesus or somebody maybe on that laptop's having some problems getting access.
Okay, so both of these you don't.
So there. If you look on your sheet of paper that I handed out, the very top thing says flashing heart. That's essentially what I just created. I went over to the left, I pulled some commands in.
I got you. I got you.
I said, okay, make a big heart.
Sorry.
Pause for a second, Nick.
I'm sorry. I was trying to show where it came from.
Make a small heart. Pause for a second. Repeat. One of the first things I tell kids about computers is they're wonderful. They do exactly what you tell them to. Then I say they stink. They do exactly what you tell them to. Right? So this is where they learn.
Yeah, and you're just pulling in case you missed it, because I saw some people a little confused. So you have two kind of coding structures here. You have on start and you have forever. So forever, it's going to get to the end, it's going to loop to the top and keep going forever. On start, it'll run it once and stop. And then all these coding structures are just off here on the side. It's color coded, so blue. You see show icon, I can just click and drag that. Now if I don't drag it anywhere, it's all hexed out, meaning it doesn't know where it's at. You gotta kind of drag it in, you can kind of see it clicks out. And so you're just gonna build that coding structure you see here off. If you pull something you don't want, you can drag it off to the side. Cool thing is it shows you what it's gonna do down here.
There's a little simulator.
Sorry.
Where did you get the heart thing?
So the heart is in basic,
Right.
and then show icon.
And then there
And
are
then
40
you
different
can
icons.
click on this drop down,
Okay, never mind, I got it.
and there's a bunch
No,
of
part of it's just finding your way around the first time and getting the
click
lay of
around,
the
you're not
land.
gonna hurt it.
Yep.
Look, I can do that.
I've only had one blown up.
Is that because you're gonna put those lights on?
But yeah, you can show icon, you can change the icon
Oh.
by clicking the drop down.
The one last part of this cycle
Making it
is that
happen.
if you haven't plugged in,
Her mom.
can you go down to the bottom left? And let's try to download it. If you click the download, it's telling me to connect to the computer. Can you hit next?
Baby.
Can you hit pair and tray? Oh, good.
Alright, just
So it's selected. Okay.
I'm gonna
Yeah.
go all again. Alright, so to stop it. So to pair, you're gonna go down, download, click it, next, pair, hopefully it's there. Next.
And then download. Next time it'll just click download. Yeah. So let me know if you're ready to download and try downloading. Click the download in the bottom right and see. I don't know what is flashing, but you can also see that the little light is blinking back there, so it's communicating with it. So when it's done, it should just flash the heart. Did you get it downloaded yet? Do you want to try?
Yeah.
So if you hit download, here, now it's
Kind of like that.
that's
Yeah.
the
Then you drag
device,
it out
so tell
and
it
with that
that's
coding structure, how we have the
connect.
heart. Yep. drag it out, put it in your
And
code.
now download.
Now it's
Next time
added. You
won't
can
have to
change
go
the
over
volume.
Why does it do that?
And now what it's going to do, you see that
Because it
flag
thinks there's an
flashing?
exterior.
That says
so on
that
the
it's
old
talking to
microbit, you had to hook up a speaker to it.
This
Yeah.
one
Now
too.
it has a built-in.
When it is done with that,
Okay.
So
So it should work.
it should work.
Wonder why it's red.
Because that's just their coding
Color, okay.
color for sound.
Okay.
very first time it's downloading a lot of extra software just to make sure
So
it's
yeah,
up to
just
date.
kind of click around.
And then, oh, there's your heart.
Doesn't look like it's good, does it?
So it's
And it's
going,
forever.
oh, so you're hearting and then showing 3 and heart. Right, so the good thing is it's doing exactly what you told it to. And what can you do? You can try a different cycle. You can put different commands in. The sheet that I gave you has things like how to add a sound. So under the red menu there are sounds, which kids love. So you can start, just start trying a few things, and we'll see what happens. You can add sound. You can make the step counter. I know it's fairly cryptic, but Nick and I are wandering down, and any questions we can help with.
Yeah.
And
Wait, do you, I did. Heart, M plus B heart. I was sure I learned something.
I might
Like,
So you,
oh, you should feel how hot this is.
and there's some
Oh look, mine's taking forever to download because mine's on Chrome.
This is my part stuff.
I don't play too much on the music. I just kind of.
The music's fun. That's what the kids go straight for.
It's fun. I just don't know how the. I think it's
Mine's still
each
downloading.
LED
Oh, his did the same
section
thing,
is a note.
Yeah, craziness.
Yeah, there you go.
I
Yeah.
was,
Oh,
The
for the,
music.
yeah, if you're sequencing. You can
Yeah.
play pre-programmed tunes, you can sequence, you can play a note
There.
for a certain amount of time. There are a lot of
If you have a
different.
lot of time, like sometimes we
What?
love to make the Mario.
Well, what you need to do is upload another program.
No, it would be a
Maybe you
week
keep in the
lesson,
background
maybe
the
2
not
week
annoying
lesson.
program. You're real fast, or you unplug it.
Or, I mean, is there other things?
Yeah,
to do?
so that is the thing that I've learned is sometimes having 2 tabs open, and on the second tab always have what I call a blank code. Just turn some LEDs on, so you know it's on there. So that way, if you get annoyed, you can just like click over that and download the a blank code.
Yeah. Feel like I'm still This is open exploration time. If anybody has any questions, let us know. Again, I printed out that sheet to just have some examples in front of you.
So how long do you think, we were talking about how long could this be a lesson in the classroom?
So,
What's your experience?
So, what we've done in the past, I worked with kids on campus and we did a big microbits workshop. And so we had them for about an hour every day. And it was about 3 days that we so like 3 hours. And we just kind of went through and started simple, like how do you hook up the microbit to this, get the basic beating heart, just kind of let them play. Then we came in a second day and we're like, all right, we're gonna try something a little more advanced. And I forgot which one we did. We did like the heartbeat sensor or something like that.
Okay. Or
We did some sensing or something like that because it's got sensors in it. And then like the third day we made a game. And then we had a 4th day where it was like, all right, now do
Freestyle?
freestyle, yeah, essentially. It was, go do whatever you want. Now there's a huge, I would say, library that Microbit has on their website where
Yeah,
you can
I'm
go
sure
through
that
and there's tutorials for a hydrometer for a plant. So it's like, find something that you like and build it,
The idea is get that first cycle, and then there are little things like, on there you'll see an example, on a pressed, do something. So if you put that little block in there, every time somebody presses the A button, it will do whatever's in that block. And so or there's on shake, do something. So part of it's exploring to see what's there, learning how some of these things work. You have your classic loops and if this or this or this or this, your logic statements. So it can start to work from there. I did a 3-hour workshop for 6th graders through high schoolers at the museum over spring break. There's just some pretty good kids. I took them up through a lot of these examples and then pulled out the robots when I really needed to get them to keep going. And they did a lot. They didn't understand everything they were doing. I would obviously want to go back and fill in the gaps, because when kids started trying to do a few things, they let me know they didn't understand. But, just by what they were doing.
it's as deep or as wide as you want it to be honest. Because then you can probably spend another 2 days going over the radio function. Like your microbit could talk to their microbit, and you can make little texting thing.
There's actually on the back there
Yeah.
is an example, because if this had gone more smoothly, getting these computers behaving, I would have been tempted to try that. If everybody codes in something like that, you'll be sharing, somebody will push a button and somebody else's microbit may do something. Which I think would be sort of fun. You don't want to do it with the kids. I'd say Nick is dubious here.
Oh, yeah.
Then you can get you can hook up normal servos, little motors. You can get little motors to hook up to them. Okay, sorry, I'll shut it.
Oh, no, that's okay.
Yeah, there's a lot. It's a very deep school.
But it's not too bad to get started, to get the idea of programming it. I am going to start board.
Other things, if you're looking to explore it, if you guys don't have computers at your school, or maybe you have iPads, again, there is an app that works pretty similarly. You just need internet and Bluetooth on it. It works the same way. It hooks up to it. The trick with it is you just gotta hook this to it. It walks you through it. It's good instructions. We found that helpful, especially older kids, high school kids, like I do. A lot of them are just I'll just do it on my phone, and it just
It's
goes
just done,
quicker.
right? Yeah. So now I don't know what next. Okay. Put that down there again.
I'm not always using them for
So that's what I said. Always have a second downloader ready with a blank code, or unplug it until you get your next code, then plug it back in. Just unplug the USB to it.
Nope.
It never turns on. But yeah, I always leave a second code open that's always blank. And then yeah, all you need to do is the USB.
The problem is,
the battery in the USB.
I think it's showing, right, so watch, you're gonna clear the screen, see the person put that dot, that dot is at location 3-2. Yeah, I have not explored that command as much as I might have. So it's just turning on a single lovely key. I'm gonna do something that's risky. I'm gonna try to get your attention now. Because there are a couple of other things I want to point out before we move along too far. one of the cool things, as Nick was inferring, is that you can buy things and plug your microbit in as the brains. So here's a small robot. Nowadays it costs about 32 bucks from DF Robot over in China. And it has 2 wheels. It has an infrared sensor, some LEDs, some nice color LEDs on the bottom. It has a little sensor that will sense how far away something is. Also has some line sensors on the bottom. But the idea is that you plug your microbit in and it is the brains. Now, what I have done that I sort of enjoy doing as a demo is I have set up this microbit to receive radio commands from another. So I'm going to turn this on and it's going to sit down here because I forgot to bring a table out to the middle. I'm going to turn this other one on and it's going to sit out here. Okay. They're both on and they're waiting for commands. Now this one, I've started using the little cardboard protectors they have. Okay, this one is actually set so that if I tilt it, it sends a command. All it did was send like a little couple of letters to it saying like clockwise, or I tilt it the other way. Okay, yeah, one of them's a little, come on, yeah, there. Not a little glitchy sometimes. If I hit both buttons, it's programmed. Come on! It's programmed to stop. Okay, I don't know. There's some debugging to do there. If I, okay, a loud noise, so they act startled. If I shake it, they all work backwards. You know, it's sort of fun. And what do? We're communicating between computers now, right? One of the challenges I realized doing that short workshop with the kids over break was the biggest challenge with something like this is everybody in the group agreeing on what the commands are. Learning that there's a lot more to programming than just randomly dragging a bunch of stuff around. You need to start to say, if I send a CW, it's going to go clockwise. If I send a CCW, it's going to go counterclockwise. Halt, it's going to stop. You know, an H. What are the commands you're sending? What channel are you going to communicate on? They have to start collaborating and getting down, you know, what it means to write specs, right? Specifications for what they're doing. So that's one of the fun things, is that you can get other stuff. This is sort of on the low end of expense. You can buy $200 robots as well that are a little fancier, but still use this. I'm going to sit back down. Sorry. I should have pulled the table out to the middle, I guess. This is one that I added to my toy list about 3 days ago. It is a cricket from Adafruit. Adafruit.com is a company that does a lot of things like this. And I plug the microbit in here. I'm not going to try plugging it in because I got a lot of stuff dangling from it. But it gives me motors, so I can make a wheel turn. It can give me servos, so I can move that back and forth. A touch sensor, so it turns out if I touch this, I have it coded so that it does something. And, oh, and I have a little motion sensor. This is sort of like what you have up in your lights. And it senses if the infrared changes a little bit. And so I've playing around with it last night instead of doing the work I should be doing. And, you know, setting up so if it did this, then the little servo went cheep, cheep, and, you know, let me know what was going on. And if I touched this, it would make a noise or play a song or, you know. But now what I've done is I've gone beyond the confines of the microbit and started hooking up more like an Arduino into the outside world. There are billions of different systems, attempts. Everybody wants your money. This was sort of expensive. It's about 30 bucks. And then the power supply that I got, because if you're running motors, you need a little bit extra current. This is like an $8 power supply. But it then sets it up to do a lot more. What I could do and plan on trying at some point is to set up 2 motors, make a little robot of my own, and then add other sensors and things like that. But still, using the microbit. The student starts early on learning how to program, learning how to work the code, but they can very easily sort of move into something like this. So that's part of what I like about them. Does anybody have any questions?
How'd you get so awesome?
I play. I hide in the basement when my wife really wants me upstairs. I'm totally kidding. You know, with the Arduinos, it was the case that some friends of mine, or a couple of different friends had said, hey, you should really check into. And I've always been wanting to play with microcontrollers, but everything that I was seeing when I was, in college, and like $150 to get started. Here was $30, and I used my old Radio Shack breadboard kit kind of thing that I grew up with as my first way of putting knobs and putting lights on and things like that. I have since spent way more than $30 on these things. Got my dad hooked. He was a physicist as well, and so he ran the motors on his telescopes in his dome outside his house in Oklahoma, things like that, using Arduinos that I helped him set up. And when he passed away, I went shopping. He would have been very glad to have me have all of it. I didn't realize how much he'd buy. These tools have, if I say maker movement, does that mean anything to people? Okay, I go in certain circles, I guess. Yeah, the maker movement is really just the whole idea that about 20 years ago, things like the Arduino, things like the microbit. Have you heard of a Raspberry Pi? With $35 you can get a little thing that you basically turn into a Linux computer. And you just use an SD card for the disk drive, and you hook it up to your TV, and everybody's got a keyboard sitting around, right? And suddenly a kid has a full Linux computer they can start learning on for $35. All of these things started becoming very accessible, making it a lot easier for people to do things. One of the scarier things is that for about $5,000 you can set up a genome splicing biochem lab in your garage. Yeah, I don't know about that. But tools are accessible. I had it just the other day. I won't name any names, but I had a student, and I'm looking for some people who have done some computer work, done some programming, and they said, well, I use the computer a lot over, spreadsheets and this and that and the other, and that's not what I was looking for. I was looking for somebody who's programmed, right? Who's actually learned how to tell computers what to do. This brings it back to basics. Suddenly you start to understand. Commodore 64, anybody? Commodore PET, the next one out was the VIC, and then the Commodore 64. That was my machine in college. Commodore 64, and the manual came with a full schematic of the circuit board. I could tell you which pin went from the processor to the interface adapter to the... Look, this was the way it was. And about 10 years later, I said, darn, this is getting too complicated. I'm not, a lot of stuff is buried. A lot of amazing work that people like Intel and all of these electrical engineers and the like have developed, but you lose some stuff. You lose an understanding of what's going on in the basics if all you do is browse the web, right? This gets kids back to, in the end, they're going to use a lot more sophisticated tools, but they're going to understand, oh yeah, that's all I'm doing. I'm using more sophisticated tools, but I'm doing the kinds of things I could do with an Arduino, with a microbit, things like that. That's my hope. I don't have as much street cred as a lot of you guys. I just go off and play on the side. I'm looking forward to the fact that we're now open at the museum and can do a little bit more. And I have no idea why we're on Teams now.
I'm trying to get into this meeting.
And why is Corey
Do you have any garage sale?
Oh, that's right, Corey was here.
Do
What?
you have any garage sale on your basement thing?
Garage sale.
Do I have any what?
Garage
Garage
sale.
sale?
For your basement.
One of my wife's major concerns is when I keel over from a heart attack, how she's going to get rid of all that crap I've done. We spent days and weeks out helping my dad's wife when he was 92 when he passed away. Don't feel sorry for him, but you know, yeah, he was living the good life. He decided that instead of walking at midnight out to the domes, he had 2 domes, 3 14-inch telescopes, some amazing cameras. Instead of doing that, he was going to learn about special relativity at 91. that was his goal over that Christmas. So, but he had a lot of stuff he didn't throw away. So, yeah, we haven't set up a yard sale yet, though Jody does know that Nick and a couple other people have full rights to basically invade and take whatever they want if I pass.
It's a good thing.
It's in good hands, good. And it's sort of fun. You can get carried away. There are a lot of curricular materials out there. I'm not as in touch with all of them, but there are setups for a variety of systems. I try to keep it cheap and accessible, but you can buy, well, they make the Dash still. Has anybody heard of Dash and Dot and Q from Wonder Labs? These are little robots that you can program with block coding, so very, very, very similar to this and to Scratch, but they have personality, actually some obnoxious personality too. So they really, well, when you randomly turn them on, instead of some of the benign beeping that these things do, they start talking to you. Why aren't you paying attention to me? All right, you get 10 of them in a room all at once. You said that, yeah, okay. But you can code them. The motors have encoders, so instead of saying go forward, you can say go forward 10 centimeters, and it will go forward 10 centimeters. So, but they're also $200 a piece. Where's the balance, right? That's part of my challenge when talking with people about what you want to get. But they have some wonderful curricula as well. Are there any questions regarding the microbits?
So I know you organize some of the events of microbits or some other things on campus.
I do. I take whatever opportunities I can to play. Let me. I don't know. Do you want a 10-minute break?
Keep going.
Well, let me pull up a little bit of the other. I will be good and not take the toys away from in front of you. So just so long as they don't get too loud. The other thing I was on the docket to talk about for a few minutes, just so you can get thoroughly sick of me before the panel discussion, is informal sort of STEAM learning and outreach, and some of the things that are going on in this region. Now, I know you're from 3 hours away. Where is everybody else from? Where are you from? You're from OU, okay. And you're from OU? Yeah.
I'm from Gloucester.
From Gloucester, so you're at Trimble with Gordon Bifford, and
Yeah.
I know Gordon. I run Long Kappa, which is something they use in the high school.
Yeah.
Not that the students like it, but because it's homework. Yeah, you're OU. You're OU. You're OU. Okay, now, when do you want to come volunteer for this? No. Sorry. Okay, well, we'll talk about this in a minute. So, like Gong said, when I got here, I was, finishing up some of my research as a nuclear experimentalist, things like that. But I started saying, my little extra time the department gives me, what I want to do is play. Get in touch with some teacher professional development. I just sort of happened into some different projects. I was part of the OSCI 5 writing team back in 2006, which made professional development for 5th grade teachers in science. That was an amazing experience because I worked with a huge gamut of people that were amazing. the key for me is that some of this extra outside stuff and some of the stuff you would do in the schools, learn by doing. That's how you're really gonna learn. It evaporated. All of the interns, we were talking over lunch and complaining about physics professors. And the whole idea that they learn better by doing, right? But in a safe, scaffolded place where you can explore. By scaffolded, when you have questions, when you hit a bump, work over that bump, right? Somebody able to walk behind you and say, well, have you tried this? Or, help you think through what you need to do. But very open-ended. Learning how to fail gracefully is important for these kids. God, I wish they knew it by the time they got to my physics class, because most of them say, I can't get this problem. And I go and look and they've done it 2 attempts, right? I think you could probably try to leverage more resources there. Learning to fail gracefully, stepping back, what happened? Let's fix it. Breaking down the silos. Does anybody know what STEAM represents, the acronym?
Science, technology, engineering, arts, and math.
Right. So science, technology, engineering, and it used to be STEM, but really the arts in there are a major breakdown of silos and a lot of fun actually in trying to integrate across the disciplines. I actually worked with the Create space up in our School of Fine Arts back 7, 8 years ago, when there was a student who was looking to have a dress. She actually had a physics undergrad degree, I think, from UVA. A dress that would light up depending on the sounds it was hearing. And she was trying to design it so that either you could use a microphone on stage and affect it, or you could work from the soundboard and you could up and down the lights on the dress on an actor in the production, right from the soundboard. Right? It was fun. It turns out, she had to pull back on her dreams, but she got some of it to work, and it was cool. Mixing in the arts brings out a lot of the creative end for the students, and it gives them a lot of motivation. There are, these tiny little microcontrollers. Here's one that's sort of Arduino based, but you could sew it into a sweatshirt and then have buttons on the sweatshirt and lights and sensors and all these kinds of things built in. Mix the arts in with the technology. So one of the big things for me is trying to break down those silos and not just saying, okay, we're just going to do this. I'm a physicist. I'm really good at just saying we're going to do this. But I want to reach out more. One of the challenges with any of the outreach for us as STEM professionals is trying to meet people where they're at. You've met the interns, right, who are an amazing group of undergrads here. But the ones who were out at lunch and have been helping move things around. And part of what they're learning is how to get into the school and meet a kid where they're at, rather than up here or down here. This is something that is a side benefit for us, is me getting undergrads involved, or grad students involved in STEM outreach. You become better communicators. You become more empathetic communicators. So that's one of the things we try. We don't always succeed. We try. These are some things I've done in the past. Library visits with snap circuits. How many people have played with snap circuits? Okay. I didn't realize I had so many OU people here. You all need to play more, all right? You need to play more. You guys are wonderful. You need to play more. The snap circuits at the library. Where all of this sort of big time started for me was we homeschooled. And I met another professor on campus who sort of liked to play too. In fact, he was an education professor whose research was gamification of education. And so he literally wrote the book on how teachers use Minecraft. All right, I mean, there is a book by Sean Dickers about yay big. I bought it off of Amazon. And more, he was looking at, hey, a new technology that really resonates with the kids come out. How do you leverage it in a way that's both educational and fun and motivational? And so he and I connected and said, let's do something. He was homeschooling, we were homeschooling, kids were sort of tween teenish. In 3 weeks, we had I don't have one of the original workshop pictures, but we had 20 families with Arduino kits, all sitting in one big room that I had a key for. Unlocked door, don't worry about telling anybody. And we had this big workshop. And we did Arduinos for a couple weeks, and then we all got Minecraft accounts. That was the death of me. I didn't realize the new one was coming out June 13th. There's any Minecraft people? Okay. Just because you're getting older does not mean you have to grow up. That was some of our later, actually that was around 2019, I think, from the stuff in the room. But we just open up and every Thursday night, come in and play for a couple hours. And maybe a kid wanted to work with some of the 3D printers or work with Arduinos or do some spaghetti towers or any number of different things. But we would just keep doing it. And then that is following over towards the museum. One of my earliest makey workshops. Anybody, have you ever heard of a makey? Okay, tiny little Arduino, but it pretends to be a keyboard or a mouse. So if you connect two wires together, or the banana piano, right? If you sit there and connect the banana to the up arrow and you ground yourself, the interns are playing with half a mind. You ground yourself, it's just exactly like pressing the up arrow on the keyboard. Now if you have a program that when you press the up arrow, you play a middle C on a piano, you have just started your piano. And you can hook up to the makey. This is banana, that's a gummy worm. And these girls figured out that they could play Tetris. Gummy worm. Every time it was as if they were pressing, every time they licked it, it was as if they were pressing a key on the keyboard. You're not supposed to lick the keyboard, but you can lick the gummy worm. It's a lot of fun for kids. It gets them thinking about physical circuits, completing a circuit, things like that. What? Yeah, well, and I have pictures of Minecraft. This is from one of our physics open houses. Back in 2005, which was the 100th anniversary of Einstein's miracle year. It was the International Year of Physics. Our department chair, who was not Eric at the time, said, let's have an open house, and we did, and it was fun. It went okay. A couple of years later, it said, we missed this. Let's do it again. Do you trust me? They trusted me. We made a few adjustments, and so every 2 years until 2019, we would basically open up the doors and have a blowout. We would do shows like what not to put in your microwave, fun with liquid nitrogen. Eric developed a show called Sharks with Lasers on Their Heads, about optics. He's our optics guy. And we would have telescope displays, we would have hovercraft up and down aisles. This is Gong's LED display that he had out in 2019, I think, 2017, somewhere in there. We got to the point where we were getting about 1,000 plus people through in a Saturday here in this tiny little backwater of Athens, Ohio. Now we had also about 120 plus volunteers. A lot of our department, our faculty really bought in. And it was an amazing training opportunity for our grad students. This is one of our amazing recently retired biophysicists, world expert in stochastic processes and the like, explaining stuff to adults and kids. Right? So these are kinds of things that we have done before. I am on the board, as I mentioned, of the Ohio Valley Museum of Discovery. It was actually an organization founded in 2006, a nonprofit. A bunch of people said, we need We need a place for kids to come, for people, for anybody to come and explore, try things, have some fun, learn in the process. And for a while we were actually, I don't know that we were really there from 2017. I think it was a shorter stint, but for a while, no, I definitely know it was in 2017. 3 or 4 years we were out in the mall here in Athens, and we finally bought our own place. There it is before renovation. There it is before renovation. After renovation, Eric's wife is on the board. I'm on the board. The idea is that it's a place to come and explore. And we got a bunch of exhibits. Now that we have our own permanent home, we have a green screen that I created back there. We have a bunch of other things that we purchased. Here are some more recent pictures. Do you recognize what that is? See, you know, little kids can be creative, especially if they're just kids. You recognize the kid.
That's my youngest.
Yeah, that is his youngest. But you know, it's a fun place. It is a place that is intended not to be a kids' science museum. It's an everybody, everything museum. We had a party, sort of fundraiser, but party for adults. We know how to get a liquor license now. And yeah, and you know, part of the deal was there were a couple of people from the board trying to talk to everybody about a couple of different things. We still had adults playing back on that magnet wall while we were trying to keep everybody's attention. You know, everybody has fun with these kinds of things. So some of the kinds of things we do through the museum, Discovery Lab is what that stuff that I started doing in the basement of the science building here morphed into. And so we are trying to now bring Discovery Lab up and online in our new space. We do field trips, people travel in, the younger kids can travel. Actually, did we have some Trimble? We had some Trimble kids come through. I
Yeah,
can't remember
my
what
son
grade.
would have came because he's in 3rd grade, but he gets in too much trouble and he got kicked off the
okay.
trip.
Even they got
Oh, that's a bummer.
preschoolers.
What?
Even they got preschoolers.
We've had some preschoolers come through as well. 3 hours away is a bit. You probably have much better places to go than this, but it would be fun.
It reminds me of like a Carnegie or.
Right.
Yeah.
In a smaller scale. We're still trying to get used to the fact that we have a lot more bills to pay. But peer engagement leaders, we do local collaborations, we hit festivals, something called Teen Science Cafe for the older kids. And so just a lot of different things that we do through the museum. Here was one that we focused on, Inclusive Science Day. How do you create an environment where students who are a little bit neurodivergent or the like are not overwhelmed? Where you have some ways to adapt to many more learners than just the average learner. There's another one. Oh, these are old pictures. Yes, they are. Newer picture. So we've been doing summer camps, and in fact, this morning we started our first through 6th grade summer camp at the local museum. So I'm waiting to see how that went. But during COVID time, we were off in other places learning about levers and balance and lots of different things. Creating some materials locally to help spread out for teachers to be able to use. And our intention is to run some teacher workshops there and the like. This is last year where Dr. Jenny Hines is a co-president of the board and one of the founding members. It's the other side of the state from you guys, but Shawnee, the Cincinnati Natural History Museum runs some teacher professional development that's really amazing. And so Jenny went out as an organic chemist, a biochemist, and did some things on color and how the organic nature of a molecule lends its color. And I was out there because I brought a 3D printer where we could make 3D molecules of DNA and things like that. So it was fun. We had a group of students for a year that we had some funding to hire them on as interns, and they developed different materials and went to science nights. along the lines of stuff we're doing, we did manage to get, I was quite surprised, we got a $10,000 grant from Infosys for programming for coding and making and things like that. And we got a $4,000 plus grant from Voinovich School through the Impact Initiative for some laptops, because now we have to have our own laptops. These are complements of engineering and maybe one or two from physics sort of thrown in. But we are going to do what I'm calling Discovery Lab Bits and Bytes. This is a picture from our microbit workshop back in March. But we're just going to get together each week. It's going to be an experiment for me, because what I'm going to do is look them in the eye the first day and say, hi, what do you want to do? I'm going to have some stuff for them to do with Scratch. But then I want to learn from them. Where are they at? Where can we take them? And try to bring in some things like microbits and stuff like that. And I'm also doing a STEM tech workshop, a team tech workshop with the assistance of Mr. Conant, right?
Yeah.
You're still on board?
Sure.
Okay. The second week of July, once he's done blowing up half of Athens. He actually helps run the fireworks in Athens every year. So legally, he is licensed. All of the fireworks at your wedding were also licensed.
Yeah.
They were actually. So that's the kind of stuff. Well, there are enough of you here from OU. See this? If you're interested. But a part of the deal is what kind of resources are around. One of the groups that I've inferred, but I did not get an explicit slide in for. Are you familiar with WOUB? Yeah. So Debbie Brewer at WOUB, who used to work at the Educational Service Center, is in charge of the the Learning Lab, WOUB Learning Lab. And things like microbits and snap circuits and little bits, which are another circuit kind of thing, a maker cart, all these kinds of things she has on there where they can be checked out by teachers, these Q robots, to try them. You know, and it's not like you can keep them forever, but you can try them out, maybe get them to run a session in a class, things like that. So WOUB Learning Lab and Debbie Brewer, and
Yeah. Awesome resource.
amazing resource, and she's trying to reach out as much as she can.
Even if you're a student teacher or something, you're looking for like, hey, I want to do microbits with the kids. You know, they have microbits that you can check out like a library essentially.
Yeah.
That's
Even though it says that I have a lot of them checked out right now. She has a lot more.
It's a great resource. That's how I got at least a little bit started, because our school's finances, they're like, but showing them that there's use for it sometimes puts their feet to the fire.
Well, and helps you get funding.
Yeah, or it helps you figure it out. Like, yeah, that's good. I want to invest in this, or we'll invest somewhere else. And using their stuff so you don't have to buy it, it's great.
So there are resources in the area. You're the one in the area. Please talk to us. If you've got anything that you're looking at and the like. And any emails you want to drop or the like. You got a little bit of a feel for the kinds of things we do, and hope to do a lot more of. So. And the rest of you, play more, talk to me. We can figure something out.
Does a lot of your local schools take advantage of this?
Well, we only opened up our doors in our permanent home in January. So we have been, we want field trips. They're one way that we actually break even. And the people we have do an amazing job with them, but we're still trying to figure out how to get more programs going and stuff like that. We've got to be a little bit careful not to overwhelm our meager staff right now. But lots of different things. Did you have any questions in general?
We'll take your email and for sure and send you.
Well, and there are a lot of people doing these kinds of things. You know, this is just something I've latched onto. I don't have any formal training in the education end and stuff like that. Sort of wing it, but there are pockets everywhere. Nick here has a makerspace degree at Nelsonville, and he is, you know, an amazing, let's try it out kind of teacher.
What is your teaching license in?
I am 7 through 12, integrated science is my license. I teach mostly high school, at the whole gambit of sciences. It's a small school up the street here at Nelsonville, York. I teach physics, physical science, chemistry. We just started a STEAM path where I teach drones, Arduino coding, 21st century manufacturing, so 3D printing, laser engraving, CNC. I'm missing other ones. But
Yeah,
I teach a lot.
I'll make a formal introduction.
Oh, yeah,
during the panel
Yeah.
discussion.
Oh, I'm so
I know. We're
sorry.
crutching.
No, you're fine.
Well, no.
But yeah, I do a whole bunch of stuff, and the district's been great about giving me power to just try stuff out.
So,
Sorry.
the microbits, as far as I understand from Gong, let's just triple check. The microbits are yours to keep.
Yes, feel free to keep them. So
If you really don't think you're gonna
if you
use
can
them,
return, that's fine. So, yeah, we're gonna have about 15 minutes break,
Before
and
the-
then we're gonna have a panel discussion at 3:45. So that one's 1 hour later.
Yeah, I'm gonna be here.
Cool. And the laptops, I think, can stay out until after the panel.